Let's now look at the shape of the distribution of numerical data. And there are two numerical summary measures that we can compute to understand the shape. One is called skewness and the other is kurtosis. Skewness gives you a measure of whether how far away the data is from a symmetric distribution. Okay, is there a tail, and is the tail to the left or to the right? And the kurtosis, on the other hand, is how peaked the distribution is, how gathered together or how tightly knit the values are, as opposed to how widespread the data and the kind of flat distribution versus peak distribution. So here are some graphic panels that we can use to understand. So here there is a skew to the left on the lower side. So here this is the median and here is the mean kind of shifting towards the tail. So that means there is a left skew. The skewness statistic will be a negative number. If you have a perfectly symmetric distribution where mean is equal to median, then your symmetric the skewness statistics will be 0. Now if there is a right side skew, tail, so then the mean gets pulled towards the tail, so the mean is greater than the median, okay, then skewness statistic will be greater than 0. Okay. Now let's look at kurtosis. Okay. The shape of the distribution, if it is flat, then you see a less than 0 kurtosis. Okay. If it is kind of a normal peakness shape, and the kurtosis is 0, and if you have a very sharp height, or the data values are tightly knit together and gives a very tall shape, sharp peak, then kurtosis will be greater than 0. Now we can compute these two values, skewness and kurtosis, using formulas, but instead what we will do is we will use Excel data analysis command that automatically generates these values for us. So let's go to Excel and generate these values. Okay, now we're going to use descriptive statistics using Excel data analysis, and we will use these 3 columns of data for the sample. So data analysis is available under data and under data analysis. If this doesn't show up in your Excel, that means it has not been turned on. So in which case you have to go to File, Options. Okay, so here go to Add-in. Under Add-in, so here Excel add-ins, click Go, and you will see data analysis tool package probably is unchecked. So check it, click OK, and the data analysis tab will appear. So then click data analysis, and there are lots of data analysis functions available under data analysis. What we want this time is descriptive statistics. So that describes the values in the sample data. So click OK, and then now you give the input range. Okay, you can have just one column of data or several columns of data here, and you can include labels also in the data, in which case you have to check this. And it is a good idea to do that. Don't ignore the labels, because if you ignore the labels, then the results that are produced are not going to have labels, and it becomes that much more difficult to understand what each column of results actually means. So here we have to select some output values here. So let's select summary statistics. We will sometimes use this one. We won't normally. There is no use for these two. Confidence level, we'll talk about that later. Okay, summary statistics. So now we have to select an output range. Okay, and make sure that your cell pointer is blinking here in the output range. Now let's select that cell as the output range and click OK, and now we get results for calories, carbohydrates, and sugar. And for some reason the labels get repeated. I don't like that, so let's clean up this a little bit. So let's move the titles over to the results area, okay, and put the results together. We don't need these labels to be repeated again. And let's get rid of that. Okay. Okay. So the format is good. So let's go ahead and have them all in the same decimal places. So here it generates our mean, median, mode, standard deviation, sample variance. So here there is the standard error, which we have not talked about yet. Okay, we'll discuss that later on in chapter 7. Okay, so we have done that, and here is kurtosis and skewness, then range, minimum, maximum, sum, and count. Okay, so there are only 3 things which we have not talked about yet. One is standard error, which we'll discuss in chapter 7. Kurtosis and skewness I just discussed in PowerPoint. So any skewness value that is negative will be left skewed, positive will be right skewed, 0 would be the basis point, that is like a normal bell-shaped distribution. So all of them are positive, so there is a slight skew to the right. Now kurtosis is how peaked the values are. So positive will be highly peaked, 0 will be normal, negative will be kind of flat. So here it's a little bit on the flatter side is what the kurtosis values are telling us.